Hi guys, this video is on logarithms. What is a logarithm, you ask? Well, a logarithm, or log for short, is the exact opposite of an exponential. And they are written in the form of log base A of B equals C. Now, when you see this word log, that means you're dealing with a logarithm. This A here is your base number. The B is your answer to your exponential, and this is your exponent. All right. Basically what that means is if this was written as an exponential, it would be A raised to C equals B. All right. That's how they convert back and forth. An easy way I tell people to remember this is remember a spiral. Okay. Start at your base, spiral up to your C value, and then come back down to your B. A raised to C equals B. Now, to go back, all you have to do is remember the same spiral. You start with A, that's your base, spiral over to the B, and then come back and end up at the C. All right, let's look at an example with some real numbers here. Log base 2 of 8. Okay, so what is the log base 2 of 8? So basically what this is asking is 2 to what power equals 8? That's basically what they're asking. So 2 raised to what power is 8? Well, you should know that x would be 3 because 2 cubed equals 8. So the correct answer for over here would be log base 2 of 8 would equal 3. All right. Over here, you could write it as 2 cubed equals 8. All right. So just remember to rewrite from a log to an exponential, just remember a spiral. Okay. This is your base, so it's the number you're starting with. This is your exponent on your exponential, and then this is the answer to your exponential. All right, A raised to C is B. All right, and here was an example, log base 2 of 8. That's basically saying 2 raised to what power is 8? Well, 2 cubed is 8, so back over here, log base 2 of 8 equals 3. All right, let's look at another example. Oops, I'm just going to pull this down. Let's look at another example. The log base 3 of 243. Okay, what does this equal? Well, if you rewrite it in log form, you're going to say 3 raised to what power is 243. Alright, so you could use your calculator and try to figure this out, or I'm gonna show you how later to actually type this into a calculator. But for now, 3 raised to what power is 243? Alright, hopefully you said 5. Alright, but that's the question you ask. 3 raised to what power? Now, if you put this in your calculator, most calculators will not let you change the base. So it's just not as easy as me saying plug it in like this into your calculator. We're going to have to wait until we get to the, I think it's in the next video, to show you how to properly punch this into a calculator. Alright, but for now, we're going to do ones that are small enough that we should be able to do with our regular calculator, not needing to know how to type this in. Alright. Here's another example. I want you to try it. Log base 4 of 1/16 equals what? See if you can figure this out. Pause the video real quick. See if you can figure out what this equals. Alright, so you know that 4 raised to some power x is going to have to give us 1/16. Alright, well, if you first concentrate on 4 raised to what power is 16, that will help. All right. So 4 raised to what power is 16? 4 raised to the second power is 16. All right. Now, what would this exponent have to be to make that 16 end up in the bottom? It'll, it'll be 2, but what are we going to have to do to the 2 to make this equal a 1 over 16? Hopefully you said make it negative. All right. 4 raised to the negative 2 power is 1 over 16 because remember, 4 to the negative 2 equals 1 over 4 squared. You should remember that from algebra. All right. Anytime you have a negative exponent, it goes into the bottom of your fraction. So here, 4 raised to the negative 2 will give us 1 over 16. So the answer here is negative 2. All right, negative 2. All right, let's move on to some common properties of logs. All right, common properties of logs. I called it common log properties. Same thing. The log base A of 1 equals 0. This will always be the log base A, doesn't matter what your base is, log base A of 1 will give you 0. Why, you might ask? And how do I know this? Well, think about it. Anything raised to the 0 power, because if you do your spiral, anything raised to the 0 power is 1. So that's how we know that the log base A of 1 will always give us 0. Second property, log base A of A equals 1. How do we know that? Well, A raised to the first power is just A. Okay. Anything raised to the first power is just what you started with. Nothing's going to change. Now, log base A of A raised to the X is going to equal X. Okay. And this is called your cancel rule. All right. That's called your cancel rule. All right. Now, next one is log base A of 0 equals negative infinity. Why does this equal negative infinity? Well, because A raised to the negative infinity equals 1 over A to infinity, which just equals 1 over infinity, which equals 0. Because remember, 1 divided by infinity is 0. And A to the infinity is a big number. So as the bottom gets bigger and bigger and bigger and bigger and bigger, this gets closer and closer to 0. So 1 over infinity is 0. So these are 4 common log properties that you're going to need to remember. So make sure you write these down and commit these to memory because you're going to need to know these. All right, so make sure you write these down and commit them to memory. All right. Now, let's move on to some graphs. All right, if you remember from the previous video, this here is your exponential graph. We'll call it y equals 2 raised to the x. Okay, it's your exponential graph. If you remember, that always goes, exponentials always go through the point 0, 1. All right, they will always go through the point 0, 1. Now, log graphs, okay, this here is your log base 2 of x. All right, your log graph will always go through the point 1, comma, 0. Okay, it will always go through the point 1, comma, 0. Because if you think about it, these are reciprocals of each other. All right, they will be reflected across the line y equals x. All right, reflected across the line, y equals x. All right, they are inverses of each other, if you want to remember it that way, and that's actually true. They are inverses of each other. Okay. So just remember that the graph of a log, unless it's been shifted, which, as you found out with the work we did today in class on exponentials, they can be shifted. But the base graph of a log will always go through the point 1, comma 0. Will always, always, always go through the point 1, comma 0. All right. Doesn't matter what the base is. Doesn't matter what the base is. Always go through here. Just like exponentials will always go through the point 0, comma 1. All right. Now natural logs. If you remember the natural base of e, if you have a log with the natural base of e, all right, it has a special name. All right. Log base e of x has a special name. It is called the natural log of x. Now the natural log will always have a base of e. All right. Natural log will always have a base of e. So 99% of the time when you see a natural log written, it will not have a base. All right, it'll look just like this. It will not have a base because the only way to get a natural log is to have a base of e. You cannot have a natural log with a base of anything other than e. All right. Now with the regular log, the common base is 10. So if you see the regular log written without a base, okay, it's an understood 10. All right, the base will be an understood 10. Just like here, it's an understood e because it's a natural log. Natural log is ln, not nl, like it sounds like it should be. It is ln, natural log. All right, some properties of natural logs are as follows. Natural log of 1 equals 0. Get e raised to the 0 equals 1. Natural log of e equals 1 because e raised to the first power is e. And then the natural log of e to the x equals x. So as you can see, these properties for natural logs are the same properties that you see for regular logs. Okay? They're the same properties that regular logs have. All right? So that's pretty much it for your kind of like an introduction video to logarithms. We will have some problems on this in class tomorrow. They shouldn't be that difficult to solve for you because like I said, this is just kind of like an intro video to logs because you might not have seen them before now. So see you tomorrow in class. There's no ticket in the door. Just be ready to tackle some log problems. All right. See you tomorrow.